Greetings, I'm John Turner. I'm the Director of Admissions for the Department of Chemical and Environmental Engineering, but more important to you, I'm also one of the admissions tutors for the Faculty of Engineering, and I'm here to give you a brief on what it is that we do within the faculty, what engineering specialisms we have, and a little bit of a taster behind each one of the MSc programs that are on offer here. I will say this now, if your questions are not answered by the end of this introduction, please get in touch with the university and we will more than happily go through any further questions you might have. So here we are, we're going to talk about engineering at the University of Nottingham. I'm going to start off with a 2-minute introduction on the General University itself, and you can find a lot more information about it than I can give you in these 2 minutes, but I just wanted to give you some of the punch points that I find to be absolutely wonderful and critical about the University in Nottingham. And I love this first montage of images that you've got in front of you here, because it nicely brings together a few of the things that automatically come to mind when you think about Nottingham. Nottingham University is one of the highest ranked universities within the UK. It is one of the highest ranked engineering departments with the UK, slightly plug on that one. It was one of the founding members of the Russell Group. It's got 40-odd thousand students enrolled in its programs here. We have 3 campuses. We're called the International University. You can study here in the UK, China and Malaysia. And we've got gold standard for our teaching and learning, which is something I'm particularly proud of. Essentially, not only are we world-class researchers, we are also world-class teachers. We've been recognised as individuals who can educate those who come to study at the university. There is a statement in there which I have to plug a little bit as well. It says lifelong career support. I graduated from the University of Nottingham. One of my degrees is from the University of Nottingham, and I still get emails as an alumni asking me how I am, wanting to know what I'm up to and how I might want the university to be involved in my career. It was ever such an interesting time when a young lady rung me up to talk to me about what I could do at the University of Nottingham, and I had to tell her, I apologise, I'm almost certain you're ringing me from the same building I am in. Wonderful to know that your university goes on with you and it's part of your existence, which I absolutely love. Another slide here talking about some of the most attractive points about the University of Nottingham, and I'm not just talking about the building you see in front of you, which is one of our high efficiency buildings. That's why it's got the grass on there and it's got the lovely air distribution system at the top, which I think is again absolutely wonderful. We mean it when we are a global university. We have a global student community. We have 150 nationalities represented within the university. We have over 10,000 international students studying with us, over 5,000 PGT students. It is a global, diverse university. I'm going to end there when it comes to talking about the General University, because I want to talk about the subject that's near and dear to my heart, which is the Faculty of Engineering. So the first thing I will highlight to you, within the Faculty of Engineering, you will find the individual engineering departments, and they range from architecture and the built environment, mechanical materials and manufacturing engineering, which we just shortened to M3, which does include aerospace at this moment in time, civil engineering, my own department, which is chemical and environmental engineering, electrical and electronics engineering. Those are the departments that you would most likely be involved with. We do have another which I do have to give a bit of a nod to, which is the foundation engineering and physical sciences department, but I believe you will mostly be interested within those top 5 departments. You're most likely looking for a home within them, and to find that home you need to know what you are studying within them. But before I just go on to that, I want to give you a little bit of information about where you would physically find us, because engineers like to work in the same territory. We like to be around other engineers, so you will find us mostly sitting at University Park or the Jubilee campus. We have got research buildings on the Jubilee campus, and we do have a lot of teaching buildings on the University Park where a lot of our offices are, and This is just a little bit of information about the university part. Universities have this site since the 1960s. It's got and is the place where one of the leading engineering faculties within the UK has grown up. We have got some information there about the general staff. There's 250 of us. But one thing I would love to highlight, and you might get a little bit of it from this image, but you'll definitely get it from the next one, is it's a lovely environment to study in. Not only because of the facilities that we have for you to physically study in, our teaching laboratories, our lecture theatres, but also the physical environment. Just look at that. You've got the Trent building and the Portland building in front of you. The Portland building, which is the long white one on the right hand side, that's where you will most likely go to eat. That's where you'll find your students' union, your shop, the hairdressers, the coffee shop, all the accoutrements that go into a student's existence. And just to the right hand side, cutting down the right edge, so over the greenery, you will find the start of the engineering departments. We are an incredibly green campus, and it makes it a wonderful place to study. You get a nicer view of it when we look at the general map, and I do love the fact they've got some graduating student sat there on the lake. Yes, this wasn't staged. You can take boats out on the lake at the right time of the year. But the campus, as you can see, is laid out in all its green refinement right in front of you there, and you'll see 2 stars on the right hand side. One says engineering. That's where you find the Coates building. That's where the Pope building is, and the Engineering Science Learning Centre. That's where you'll be lectured. That's where you'll be taught, and that's where most of our offices are, so most of your lecturers will be there. And if you're in architecture and the built environment, you'll see another star up the top. You have a separate area because you've got those low energy and high efficiency buildings that you need to study and work on, and they needed a separate section of ground to be operated on as well. So those are the 2 areas that you would find most of the engineering staff, and you would spend a good chunk of your life. But there is another area. There's the Jubilee campus. Here's the Jubilee campus on the right hand side. We have some research buildings there, and we are starting to show students around these, so this is something that you might also see in the future. I know it's often important. People want to know about rankings within league tables. Wherever you look on the left-hand side of this slide, you will see one thing. We're in the top 15 no matter where you're looking. If you look even closer than that, you'll see some of them are in the top 5. What you can take from this is whichever department you are studying in, you are in a highly reputable department. What we are giving you is a first-class education. You're here to study, you're here to get a master's within a specific field of engineering. You will find that you have got academics and facilities that can help you attain such a high quality qualification. So wherever you go down there, you're going to find us in very good positions. Electrical engineering, 1st in the Guardian League table. Chemical engineering, 3rd in the Guardian League table. All looking very good. Just like to point out, the picture that's of chemical engineering on the right hand side just there is literally in my laboratory. Those are my students doing a reaction on one of our 1st year projects. Next, let us talk about our courses. One of the first things you can see here is that many of them are accredited by professional organisations, which means what we teach our students and what our students are able to do by the time they complete their masters is recognised by industrial bodies as what is needed to be that engineer. So the IChemE gives us a stamp of approval to say when you finish the MSc in chemical engineering, you have the skills that a chemical engineer needs. That's important. It's officially giving you that little bit of clout behind you to say, I have the ability to do what I am qualified to do. On the right hand side, I just want to give you an idea of some of the companies, and this is an incredibly small number of the companies that we have links to, that we know we've had students go out on. Some of the ones that come to my mind straight away is, yes, we've got Shell, we've got BP, the oil industries. We've had students go out and do year-in placements at BP. We've had students who have graduated and gone on to work at BP, Shell and these other companies. These are the companies that we are communicating with, that have an involvement with our departments, that are involved with the evolution of our students' understanding as well, because in the end, when you are qualified, you need to know that there is an industry out there that wants what you have trained to do, and having the support of that industry as you go through the qualifications is a nice indication that that is the case. So the first department here is the Department of Architecture and the Built Environment. And what I would like to do is to give you a breakdown of some of the courses that they make available to you and what you might do in some of these programs. So the first thing we can say is we've got two main areas, which is the MArch and the MSc. So you could do programs in architectural design, architecture and sustainable design. You could do an they're both MArchs. You could do an MSc in sustainable building technologies or sustainable energy and entrepreneurship. There are a load of different courses available, and I just want to give you an idea of what might be contained in a couple of them. So I'm going to go for the first one on the list there, which is architectural design, which mainly focuses on specialized architectural knowledge and advanced design technologies and techniques for the urban environment. So it's in response to the increased and changed demand for building construction and the need within those buildings that you would find in large urban areas. As you think about it, what is being built in the centre of cities and the urban environment itself has evolved over time. Consequently, the skills and understanding you need has also had to evolve, and this program is one of the responses to that need. It allows you to have this advanced architectural understanding without actually having to specialize in an individual area. So you're gaining high level skills and knowledge, but without having to focus or curtail yourself in a single area. And some of the programs that you might find yourself studying because of this are urban design theories and practices, which basically introduce and analyze the contemporary urban designs and theories, including their evolution from historical practice to the development or developing a critical understanding of the contemporary city and how people engage with it. So that could be one of the modules that you might study. You've got another one that centers on design fabrication, which is essentially introduction of the theme and ideas and practices involved in the emerging field of architectural fabrication. It does cover traditional and digital approaches and steps and skills needed for the use in fabrication as a design tool and as a design output. So that's one of the programs that you could be studying within architecture and the built environment. Another program that could be studied could be the MSc in Sustainable Building Technologies. Now this has been tailored towards those who work within building services, architectural, environmental engineering, architecture, and other fields related to the appropriate application of effective use of built spaces. The program's designed to explore building design and technologies and building energy and environmental performances. It's looking at how a space is used, how things can be integrated into that space to gain more effective application of energies, of materials, how the building itself operates. Some of the modules you could expect to study within this program are things like cooling and heating systems and their application within the buildings. So you'll develop an understanding of air conditioning technologies and develop skills in the design of air conditioning technologies. Some of the other ones would be renewable energy technologies and design within built environments. So analysing the performance and system designs and sizings of renewable energy sources for a building. There's no point in putting a giant solar panel array on top of a building that could never use the energy produced by it. It does emphasize things like solar energy technologies, both the photovoltaic and solar thermal, small scale wind turbines, how these are applied, how you would analyze the application of them to specific builds. Now that is just a small look at the department. There are many other programs, MSCs and MArchs for you to explore there, and I would encourage you to go online, look through the individual programs, because there's always something that you will find interesting within them, and that will direct you towards what your area of study might be, what your area of interest might be. The next department to be studied is my own department of Chemical and Environmental Engineering, and again we've got a wealth of MSc programs for you to explore and find your interest in. I'm going to again select just a couple of them to talk through, but overall we've got chemical, we've got environmental, we've got energy process systems, and we've got food process engineering. The modern world demands new innovative technologies to make products. That's what chemical, environmental, process and energy process engineers do. We make products, be they chemicals that run your car to chemicals that you eat in food processing. We make products, harvest and conserve resources and use energy efficiently. That's what the backbone of these programs are all about. They're allowing you to understand, to advance your already formidable knowledge within these fields to the next level, to be able to develop new innovative technologies for the next generation. I'm going to select one of these, which is, I think, kind of obvious. I'll go for chemical engineering straight away. The idea behind the chemical engineering program is to give you that additional training that companies now expect the new generations of chemical engineers to have, to produce a graduate that has exceptional skills and applicable industrial understanding for the modern industrial complex. Some of the modules that you might be studying in there could be renewable energies from waste. The module looks at different ways of using industrial, domestic or agricultural waste processes to develop new energy sources. Consequently, you'll need to know what a fuel is, how it is made up, how to scale the energy production that you're going to be making, whether it's going to be small, medium or large is probably based on the waste stream that you're looking at. But it's necessary for you to understand and be able to build a production line and process from an understanding of that scale. You're going to be looking at the application of future energy sources and trying to determine what energy source will come next rather than what is being used at the moment. You'll also need to have a comprehension of where you are globally. So indigenous fuels change based on where you are actually doing the process, where your plant is operating. And this needs to be understood so it can be exploited effectively and emphasize the sustainable nature of the energy that you're trying to exploit. Another module you might be interested in would be multi-phase systems. Why? Because whenever you have a reactive process and it produces a product, there's a good chance you might get two things coming out of it. And these two things might not be flowing in the same direction, have the same phase as each other, which means you might have liquids and gases pumping out of a process. And you need to understand how to use these, how to not allow them to influence each other, or how to use them effectively to influence each other and gain as much as you possibly can from them. So you need to have an understanding of these things. So the modules are designed to build on what you already have and push it further to give you advanced understanding of how to apply different principles. Another program you might be interested in would be the food process engineering. Food is an incredibly important commodity for the planet. Unlike other manufacturing industries that are developed during the Industrial Revolution, the food industry has always been about the basic supply of human need. It's developed incredibly over the last 50 years, mainly being commodity driven, branded values, cost driven profit models. However, as the evolution of technology and society has progressed, so has a realization that food sources, natural resources, are finite. Therefore, a new dimension has come about, the dimension of the growth and profitability of how to environmentally and sustainably produce food products. And effectively, this has led to a need to re-engineer the food production system as we have always known it. And as a consequence of that, that's what this program looks at. This need to re-engineer our existing food systems from a consumer's perspective, environmental concerns, future populations and urban growth, and/or a greater societal cost, creates no doubt that a fundamental rethinking and radical redesign of the entire food chain and its practices is required. That's what this program is trying to give you a look at. That is what this program is designed to try and give you an appreciation of. You're being shown modern food process techniques, the sustainable and environmental production of food products. Civil engineering advances the technical knowledge and experience needed by students to develop analytical, decision-making and critical thinking skills within a civil context. Some of the modules that you might be exploring within civil engineering could be the geotectonics modelling, which will reinforce and advance some of the principles of soil mechanics that you might have previously learned in undergraduate degrees, describes the principles of critical state soil mechanisms and the models used to predict the behaviour of soils. Students will use different pieces of software to perform geotechnical analysis as well as doing physical modelling using geotechnical centrifuge. The idea behind the module is to allow students to build an advanced understanding of soil mechanics. One of the modules you could study could be coastal engineering, which introduces and explores waves, tides, wave generated and tidal currents, beach sedimentation and tidal energies. It gives you a conceptual idea of coastal engineering, the effects of these different forces on coastlines and how they might be exploited, how they might be measured, and how they might be influencing the coastal makeup around them. Another program that could be studied would be Transportation Infrastructure Engineering MSc. The program focuses primarily on sustainability, the sustainability of the highways and railway infrastructure. It develops a physical understanding of the constituent materials of roads and railway infrastructure and of their deterioration due to their use, the traffic that's going over them, the environment that you find them in, the modern environment they are exposed to, i.e. the conditions resultant from different traffic, different gases given off, and how to manage and understand the deterioration of these infrastructures. And as a consequence of this understanding, it helps you apply techniques to assess the condition and to manage that condition of these transport infrastructures, to extend the reliable lives of them, to increase the life cycle, and to provide sustainable services into the future. One of the modules you might study there would be Railway Infrastructure Engineering. This module provides an overview of the railway as a total system, including operational issues, signalling and control, but with the concentration on the track and the management of the electrical and mechanical engineering systems of that track. Another module could be Highway Infrastructural Engineering, an understanding of the highway's layout, concentrating on the effects of numbers of lanes on the junction designs, design of pavements, the structure of the pavements, the surfaces that are being used. An in-depth understanding of both of these transportation infrastructures is key behind this MSc. The next department for consideration is the Department of Electrical and Electronic Engineering, and the MSc selection you've got here ranges from broad spectrum MSc topics that include a wealth of electrical and electronic understanding to more specialised MSc programs like power electronics and drives. So taking one of these examples, we'll look at the MSc in Electrical and Electronic Engineering, and that's designed to deliver a broad-based understanding of the artistry of electrical and electronic engineering and an in-depth study of the topics covering modern technology. And these can include electrical design or electronic design, communications, software engineering, power generation and distribution, electrical machines, and renewable energy sources. The objective here is to give you the confidence to be able to apply this in-depth understanding in the industrial context. An example of a module you might study could be electrical machines, drive systems and applications, where you'll get an understanding of the operational characteristics of common electrical machines, both the theoretical and practical characteristics. This can include things like electrical magnetic theory applied to electrical machines, principles and structures of DC machines, and other such topics. Another module could be renewable generation technologies, which covers the analysis and design of renewable and sustainable energy systems. And the idea is for you to be able to explore the types of renewable energy and resources available, such as wind power, hydroelectric, tidal, solar, etc., etc., but to gain an understanding of the physical principles of these different energy resources in order to develop analytical models which will be applied to the design of these energy systems. Another MSc option could be Sustainable Energy Engineering, which is a program that enables students to be able to assess the different energy supply options to gain a comprehensive understanding of modern, sustainable, renewable and conventional technologies from a wide range of applications. This is primarily in response to the growth of the energy sector, especially in these new and emerging energy technologies. The industrial requirements which want the graduates to be able to have this specialized knowledge and this multidisciplinary ability to span different energy technologies and resources. And the program's designed to give you that ability to understand and analyze a wealth of energy technologies from a more practical engineering standpoint. One of the modules you could study here could be Engineering Sustainability, which is designed to provide you with the knowledge of key environmental and sustainable issues of relevance to the energy sector and to energy supplies and usage, the materials that are consumed in the energy system itself, and the products and designs that are manufactured as a consequence of this. You could be doing such things as drivers for sustainability, the things that are making the energy system change and alter for the new environment in which it exists, factors that are influencing the availability of non-renewable and renewable energy sources, principles for the efficient use of the energy resources, including energy in buildings, heat and power generation, and a wealth of different other considerations around the energy and sustainable energy applications. One of the key issues that presents itself when it comes to energy is energy storage, and we've got a module here that aims to provide you with the fundamental knowledge and practical skills in relation to how energy is stored, the science behind it, from fossil fuels such as fuel storage in coal, oil, natural gas, etc., etc., to mechanical energy from springs, heat and thermal, electrical storage, and the integration of energy into different storage and supply systems. The next department for consideration is the Department of Mechanical Materials and Manufacturing Engineering, and there is a wealth of different MSc programs available that span that three dynamic areas of engineering. In addition to this, within this department you'll find the aerospace engineering programs as well. The topics studied within M3 are vast, and I encourage you to explore each one of them because it moves from emerging technologies to already established methods, technologies, to the application of new development to pre-existing technical fields such as aviation, automation, electronics. M3 offers courses that cover specialist and advanced engineering subjects, combined expertise in mechanical materials, manufacturing engineering, and the impact of humans upon products and process systems. Essentially, the programs within the department allow a student to be involved with the development of new techniques, new technology, and their application of these new techniques and technology to pre-existing and future applications. Prime example of these are the application of 3D technology and 3D printing methodology to already existing production lines to improve upon what is there through 3D printing manufacturing techniques. One of the MScs you could study could be the Additive Manufacturing and 3D Printing MSc, which allows you to develop an understanding of how new manufacturing techniques are being applied, such as 3D printing. The aim of the program is to examine the implementation and theory of additive manufacturing, its translation into modern additive manufacturing techniques that are currently being researched and exploited, and allow you to develop an understanding of the application of these new manufacturing techniques such as powder bed fusion, material extrusion, sheet lamination, and the integration of aspects of 3D printing, 3D scanning, and the impact of additive manufacturing and 3D printing on the industrial world. Another module that you might take could be Materials Design Against Failure. This module focuses on understanding and manipulation of materials microstructure to avoid failures, breakages, and the deterioration of these materials once they've been used in manufacturing. It addresses the main areas of mechanical failure using specific material systems, examples to illustrate how materials design is used to develop better material for particular applications. You could be looking at such things as metallic alloys, ceramics, and an analysis of the characteristics of these materials. Another MSc that could be studied could be the MSc in Aerospace Technology. This is an MSc designed to provide a solid grounding in current aerospace technologies, together with the options to develop an emphasis in manufacturing, advanced materials and structure, power generation systems, and aerospace navigational technologies. Due to the unique nature of this MSc, it's actually been broken up into 4 areas: aerospace manufacturing, aerospace material and structure, aerospace power and electronic systems, aerospace navigational technologies, in which students are allowed to choose which stream they wish to study and become specialists within that area. The MSc program gives you a grounding within a specific area of aerospace and allows graduates to go on into the aerospace industry or potential research within this new and cutting-edge development. One of the modules that you could be studying could be Aerospace Industry Organisations. This module offers a comprehensive account of the organisational practices across the aerospace industry worldwide, and it gives you an understanding of how the industry as a field operates, but also about the individual character of a different range of companies that you're most likely going to encounter within the aerospace industry. As a consequence of this, some of these companies, some of these industrial leaders actually come into the university to give operational discussions on how their organisation fits into this wider concept of global aerospace. Another module you might experience could be Flexible Automated Manufacturing, which introduces the basic concept of advanced automated manufacturing principles, how the automating system operates on a factory or global scale, how it can be used, the principles behind it, and its application within different contexts. That is just a small extract of the MScs and specialised courses available here within the Faculty of Engineering, and I strongly advise you to explore the different modules, the different programs of study that you might be interested in, because it doesn't reflect the true depth of subjects available here in the Faculty of Engineering. I would like to just end with this one slide because I know it can be quite important to some individuals out there. It is an indicator of the English language requirements that you will find across the different departments within the Faculty of Engineering. It also indicates some of our Sealy programs that would be available to you. If the IELTS are not what you have obtained, you can do pre-sessional English courses called Sealy programs that can help you attain the required IELTS for entrance onto our MSc program. So if you are having a challenging time with the IELTS, I advise you to look at the Sealy programs that are available. I am going to end there, and I'm going to end with a slide that you would normally find at the end of any presentation, which is any questions. Nottingham University, the Faculty of Engineering, is a very open book place. If you have any questions, I strongly recommend that you contact the Director of Admissions for the department you're interested in and ask those questions. We are always receptive to student enquiries about our subjects because there is a wealth of individuals here who thoroughly enjoy to talk about their specialist topics. I hope you enjoyed this presentation. It's been absolutely wonderful to give it. I thoroughly enjoy talking about the Faculty of Engineering and my topic specifically. I hope you have enjoyed it as well, and please feel free to get in touch. Thank you kindly.